Very good morning, dear friends, and myself, Dr. Hemant Chennaiya. In today's video, we are going to study about the development of the lateral surface of a square pyramid having base edge 30 and height 60 cut by two section planes. And these two section planes are parallel to, as inclined to HP, as inclined to the XY, and perpendicular to VP. And hence, friends, these two are seen as lines in the front view. So let us start with the drawing of the top and front view when two adjacent edges of the pyramid are equally inclined to VP. Friends, I construct a square here, square ABCD. And this is the top view of the base of the pyramid, which has got a measurement of 30 All the four edges measure 30 millimeter. And let us join these diagonals to obtain O, the vertex. So we'll call it as A, this is B, this is C, and this is D. So these are the four base edges. Let us obtain the base in the front view by drawing the projectors through all these points. So this is how we obtain A dash, B dash, D dash, and C dash here. So I will mark it as A dash here, A dash, this is BD, B dash, D dash. The last point is C dash. The midpoint where these two diagonals meet is O, the vertex. So friends, on this, let us find out or draw the axis having height is equal to 60 millimeter. I mark a height of 60 millimeter. That is the height of the pyramid in the front view. So now this is O dash, the front view of the vertex. And let's join all these corners A, B, C, D to O dash. So I will join O dash to A dash, O dash to C dash, and this O dash to B dash, and O dash to D dash. This is our point O1, which I'll mark here or here. O1. Friend, this is the axis which is normal to HP. Friends, now this pyramid resting on HP in this position with two of the base edges equally inclined to VP. Say this is 45 degrees. Is cut by two section planes. So before you move on to the section plane, let us draw the development of the lateral surface of this square pyramid, assuming it is not cut by any section plane. And hence, friends, we will draw a vertical line of length is equal to O dash C dash. This is O. This is O dash C dash is the true length because OC is parallel to VP. When a line is parallel to VP, the corresponding front view will give you the true length. So this is the true length I have got. Friends, I am going to draw an arc from here, arc from this point at the end of this, and on this arc I am going to step off four distances, each measuring 30. So from here I will take 30, 30. So let us take it to smaller length. So this is 30, 30, this is 30, and this distance 30. So we are going to join all these by thin lines to start with. So friends, this is how the development looks when The solid is not cut by any section plane. This is going to be just four isosceles triangles on the development. Now friends, let us mark the section planes and see how it is cutting the pyramid. So there are two section planes, both being normal to VP. So very obviously, these two section planes are seen as lines in the front view. He says, yes, it's cut by two SPS. SPS means section plane. One section plane, one, is inclined at 30 degrees to HP and passes through a corner of base. Friends, A dash and C dash are corners, extreme corners of the base. And there is one section plane which is passing through this corner and inclined at an angle of 30 degrees to horizontal. So this is 30 degree. We'll call it as S1, S1. So this section plane is inclined at 30 degrees to HP and it is normal to VP. Now friends, let us draw or obtain the points where this section plane is cutting in the development. So friends, the section plane S1, S1 is passing through EA, passing through OB and OD are cutting these two OT edges and again this OC. So three slant edges are cut by the section plane while passing through the corner A. Now friends, before we draw that in the development, let us mark the portion that is retained for the purpose of development. They are the development of portion of pyramid that lies between two section planes. So this is section plane 1 and friend there is section plane 2 passes at a distance of 25 millimeter from SP1. SP1 is here and this section plane S2, S2, the second section plane is also parallel or inclined to HP at 45 degree, 30 degree and it is passing at a distance of 25 millimeter from SP1. So I'm going to draw S2, S2 at a distance of 25 millimeter from S1, S1 and we are interested to have the development of the portion that is between S1, S1, S2. This part we need to draw the development. So friends, here let us mark the point where all it is cutting. It is cutting SP or SP2 is cutting OC here, OB, OD here and this point is on OA. Likewise, S1 is cutting here these two vertical edges and passing through corner. And we are interested to obtain the development of the portion of the pyramid that is between these two lines. I want the development of this. Friends, here none of the slant edges are completely removed by the section plane. So you can start the development or commence the development from any point of your choice. Say let us start from this point A. So this is point A, this is B, this length is 30, remember, order of 30. This is C, this is B, and again this is A. So all these lengths are 30 millimeter each. And friend, this is also the true length. And here, let us mark the points where the section plane is cutting the solid, cut by the section plane 1, 1. Friends, for 1, 1, it is passing through A of the base. So I am taking only the section plane 1, 1. Then it is cutting vertical edges OB and OD here. It is not the true length. Hence I shift that to the last line which is the true length and take this measurement on OB, OD. OB, OD, I will have this measurement. On OB I will take, on OD I will take. These two measurements are the same on OB, OD. it is cutting O dash C dash here. So I will take this measurement on this straight because it's a true length. I will take on OC this length little up. Friends, this is how the object is cut by section plane 1 1. So friends, similarly, if you consider the section plane 2 2, which is at a distance of 25 millimeter, friends, let us see where all it is cutting. It is cutting slant edge OA, that's O dash A dash at this point. And this is also true length. We want you can take straight from this, or you can shift there and get it. So since OA is also true length, O dash A dash, you can take this and mark on OA. And just mark it on OA, a point there. Then OB and OD are cut here. This is not the true length. Shift it to the true length and make the measurement on OB OD. This is on OB. OB is going to be closer to apex. So this is on OB. You get a point, and OD you get another point. OB and OD. Finally on OC you are going to get OE. You have to mark again here, and because it's a common point on both OA. And friends, I have to get points on OA. We got points, 2 points on OA, 2 on OD, and on OC. This is the true length. OC is the true length. Mark on OC. So friends, on each of these slant edges, you are having 2 points. 1 point here, one here, 1 point here, one here, one here, and one here. Totally, we have got 2 points on every slant edge of the pyramid. So friends, let us take the section plane 1 1 and join all those points obtained by section plane 1 1. So friends, this is the line we are getting second, third, and this is fourth. So these are the points which are obtained in the development when the solid is cut by section plane 1 1. Similarly, for the section plane 2 2 friends, we have to obtain the points obtained by straight lines. This is how the development looks. And friends, the edges that on OA, the bottom portion is retained. So this is retained. I have to show by full line. This is also by full line. And all these slant edges are also retained. And friends, this portion that is from here, this will give you the complete development. If you want, let us mark them also. This is 1 on the bottom, 0.1, 0.1. On OB and OD, 2, 3, 4, 2 and 4 on OB and OD, 2, 4 on OB and OD, OB2, and this is 4 and that. Then on OC, it is going to be 1, 2, 3, 3 on OC. So 1, 2, 3, 4, 1 are the points on the development cut by the section plane S1, S1. Similarly, for this, we can call it as dashes with the same number. So this is going to be 1 dash. This is 2, 4, 2 dash, 4 dash, and this is 3 dash, 3 dash. So we have that. This is 1 dash, this is 1 dash, this is 2 dash, 3 dash, and this is 4 dash. And remember friends, 1 dash 1 is this. 1 dash on both the sides. 4 dash 4 is for this. And similarly, for these 2 2 you have got 3 3, all this you have got. And friends, this portion shown here, that is 1 dash, 2 dash, 3 dash, 4 dash, this figure will give you the development of the part P, that is in between the two section planes S1 and S2, separated by a distance 25 mm, and both the section planes are normal to VP and inclined at 30 degrees to HP. Friends, I can mark this portion as development of P, the portion between two section planes. Friends, I hope the presentation was interesting, and if you like this video, do share with all your friends without fail. Thank you very much and have a wonderful day.